right, so when we're doing this problem, I've got my drawing here, and the things that it's telling me from the problem itself is that she's up in the tree and she's 10 meters up. So my change in the y direction is going to be a negative 10 meters. I also know that acceleration is going to be negative 10 meters per second, and that's really all I know about the y. On the x side, all I know is that the initial acceleration is going to be 0. So it looks like I don't have very much to solve for, but I do also have the fact that I've got an angle here of 30 degrees. I also have that the final velocity, okay, my hypotenuse is going to be 15 meters per second. So I can use those things to kind of determine some of the missing variables. So the first one is I need to find out what is the velocity in the, I'm trying to see which one, I guess I did the velocity in the x direction is going to be equal to 15 cosine of 30. So the velocity in the x direction ends up being 12.99. So if I'm just going to draw my triangle again here and just kind of fill it in. This is 15 meters per second, and I've just determined that in the x direction it's 12.99. That's x. That's x. Okay. All right, now I'm going to determine the velocity in the y direction. And to do that, I'm going to take 15 times the sine of 30. And that's going to give me a velocity in the y direction that is negative 7.5 meters per second. So that's going to go negative 7.5 meters per second. So now I've got all the sides, and I can now start to fill in my box. So in the x direction, my velocity is 12.99. In the y direction, it's 7.5 meters per second. So now I can use that to determine the time, and I could use a variety of different formulas, but I'm going to use, where did my time go? Okay, I ended up using this formula here. So my final velocity in the y direction, my initial velocity in the y direction squared, plus 2 times my acceleration, and then change in y. So I substitute my numbers in, my final velocity in the y. Whoops, hang on, that's not correct. That's not solving for time. Back up. Yes, that is the one to use. Yeah, because you don't have time in that one. So we're looking for the speed of the stick, so hang on, we're not quite there yet. I don't think we need time. No, we don't. We just want final velocity. So I do have the right formula. So, but if we do it this way, I don't need time. 2 times a delta y. So now I can find my final speed, which is the final velocity, is equal to negative 7.5 squared plus 2 times negative 10 times negative 10. When you solve for that, the final velocity is going to be 16 meters per second. Now, if it's 16 meters per second, yeah, no, I'm sorry. I have to add on Oops, hey, sorry, my thing is going crazy here. Don't there. So now I've got 16 meters per second as the final velocity. And I did a horrible job showing where I went next. Here's what the next thing I've got written down. My speed is going to be equal to 12.99 squared plus 16 squared, and that equals 20.6.
Could you just do 15 at the for initial velocity? That's what
What's that?
Could you use the 15 squared as initial velocity?
You could, yes, yeah. Yeah, there's a couple different ways to do this.
I know the time and then that whole. I know the time.
You can work, like with any of these problems, if you solve for time, you can figure it out. As long as you're getting the 20.6, you can take any path you need to, okay? But that's one of the ways to get to the final answer. All right? Now, for B, and that's the one that you guys seem to struggle with the most. Let me just move this up a little bit.
Well, I figured out what I did.
Okay, good, good.
The variables.
All right, I'm gonna draw this out just because I want to be able to post this so Isabella can see the answers here. So the question is, how far away from the base of the tree do the wolves need to be in order to get hit by the sticks? So I'm just going to really quickly, here's my right triangle again. This side was 16 meters per second. This side was 12.99. We had a 30-degree angle. And I need to find x. So what I did was determine the time. Which the time ended up being, just double check yourself on the time. I got 0.85 seconds. Is that what you guys got? Did you guys get the time?
Mm-hmm.
You did.
I think I did it wrong.
Okay, should be 0.85 seconds. Then when I'm solving for x, I've got my 12.99 times 0.85 plus 1/2, and the acceleration is 0, so that's just going to get rid of everything on that side. But I'll put in there, and when you solve for the displacement for x, it is going to be 11.05 meters, or 11. Are we good? Yes? No? Maybe? You guys aren't saying anything.
Too tired.
Okay, but give me some feedback here.
I'm looking.
Okay.
I'm really trying to figure out what I did wrong.
All right.
Where I got lost. Because apparently it was a little bit.
C is 20.6.
Yeah, exactly right.
All right, you good? All right, one last question. And that's a video thing, so I'm going to stop this.